Right. So let me revise whatever we have done yesterday. I think it will be really very quick recap. So first of all, I'm just giving this file again, and if it is not working for you, let me know. So the same file you have to download again, delete the existing one, the one you had. Okay, and I'm just accessing my Kubernetes master node, and here in my Kubernetes master, I'm just going to www.html, and I'm opening admin.conf file, and I'm changing this. So delete the existing file and copy this one. Okay, so I'm just copying wget http://this/admin.conf. Okay, it is now downloaded in my machine without any changes. Okay, you can download from there as well, right? You know that. If you don't want to use wget in Windows or some machine, you can just download from your browser also. .conf. Okay, see, when you are downloading it, make sure the IP address is right here. You don't have to change anything. Just download this, save as, and whenever you download it, now you try to connect by get nodes --cube config admin.conf. Without making any changes, you must be able to, all people must be able to do that. This is final testing, because tomorrow you will be getting an email address about this admin.conf. You don't have to use this file for tomorrow exam. You all will be getting your own admin.conf file. Okay, this is just for testing. Alright, so just try and let me know. Download without making any changes. Okay, and let me know, is it working or not. So download and check, and then type yes or no message. Yes for if you are able to connect, and no if you are not able to connect. Alright, so working, connected, and please make sure you are able to connect. You don't have to make any changes, that is very clear, so that tomorrow you'll be getting email address right. So I can see few yes messages. Okay, so I think it's working fine. Alright, now I'm starting this session because I have to cover a lot of things. So anyway, now I think you might having a quite good feeling about Docker first. Okay, so the journey we started in the world of DevOps, we as an engineer, we always has to, take a code and integrate with the Docker file. And by integrating this, we have to make effort to create a Docker image. Okay. And Docker image must be kept on a very secure and worldwide accessible place, so anybody can download that one. Okay, so I think I need to cross check my again charging point anyway, but this must be very much clear that you have to create a Docker image for your code, and after that this image must be uploaded on any of the location like Docker Hub. Okay, now if this is uploaded like Docker Hub or GCR or Azure Container Registry or QUAI, right? So a couple of registry are there. Then any other deployment tools, they can use it without any problem. Fine. So simply creation of Docker images is not a problem, and this will be the base question in your Kubernetes examination. Okay, that means this question will be primary, because if you're not able to perform this question, that will be question number first. Okay, Docker image creation from Docker file, even the multi-application image. Then there are so many tools where this Docker image can be deployed. Okay, so deploy means now you want to make your website testing or application testing, or you want to make it live or worldwide. So to deploy, we have couple of options, like we have Docker Swarm, right? We have Rancher, and we have Kubernetes, and we have OpenShift Container Platform, right? So Docker Swarm, Rancher, Kubernetes, OpenShift, and many more. Okay, but out of these big list, we are talking about Kubernetes, and Kubernetes is one of the premium product in IT industry as of now. Okay, so anyway, if you wanna compare these products, you can compare it, and you can read about them on Google. But we started with Kubernetes. Okay, so once Docker image is stored on any of the registry like Docker Hub, like QUAI, like GCR, or any places. Okay, then from here Kubernetes master or Kubernetes minion can connect by a couple of ways. Okay, master always need to be connected by a client, and client machine can be used as Windows, Linux, or Mac, but you need to install this software in the client machine. Then you need to download some authentication file. In my case, the file name is admin.conf, and this admin.conf is directly connecting to QAPI server. And then everything is happening as it is. Okay, that you know how the flow is going on. Okay, now if you have Docker image available in any of the place like this, then to deploy a containerized application in the world of Kubernetes, we as a administrator, we started our journey with the pod. Okay, we have seen a couple of examples in pod, how we can create pod file, driver, and many more things. Then to access this pod, we moved to a new API resources called services. Okay, we know that pod has many problems, that pod cannot be scaled automatically, or if the pod goes down, it cannot come up automatically. So The better way we found to deploy your application is a replication controller. Okay. Let me tell you one thing. Replication controller is also a component in the Kubernetes master, but replication controller is also an API resource in Kubernetes. So don't be confused that this replication controller and this replication controller, they both are same. No, they both are not same. Okay. So that replication controller means it can support any container scaling technology, but this is just a type like a pod. Okay. So service is entirely different thing that we created, and we are moving from pod to replication controller. And I believe we have learned a lot. That means yes, how we can write a replication controller file. And I believe I have also uploaded that data on my GitHub account about replication controller. You can cross check on my GitHub repo. Yes, that is there. Okay. So if till now everything is okay, very much okay, and understanding, I mean you're able to understand it, then say yes in the chat window so that we can talk about what we are going to learn today. Right? So just waiting for your response. And so for hers, it's all right. Yes, it is very much rhythm hers. Okay. Fine. So I'm okay. Getting response positively. That means yes, it's very much easy to understand. All right. Now let me just show you that file, the one, my first replication controller I got created. Okay. So see right here. Okay. Now the replicas we have deployed. So as of now, if I have anything and nodes, yes, and I'm deleting every single thing whatever I deployed yesterday so that we can deploy it very fresh. Okay. So this command will delete everything, means it will delete pod, it will delete replication controller, it will delete services, whatever we have. See, now if I'll show you kubectl get pods, it is in the terminating state and we don't have anything else now. Okay, no worries. So now I'm going to just deploy this. This time I'll make my replica as a 2. That means how many pods I want 2 pods. Okay. Now you can understand first of all why we need 2 pods. So for example, we have Kubernetes master and we have Kubernetes minions. There are 3 minions are there and they all are connected. Okay. So as a normal web application developer, you deployed your application on the Kubernetes and this is your pod that is running. Okay. So your pod is running. Okay. So what is happening when you create your pod, you have to create a service and that service will be exposed to your Kubernetes cluster by node port or the balancer. Now these are people who are accessing by hitting this any of the IP and some port number. Okay. So this is working very fine as of now. But if sometime you feel like your website is pretty slow because the number of accessors or number of users are increasing day by day. So for example, there is a formula. A pod, let's say a pod cannot handle 30,000 requests per second. That means the web application that you deployed on the worker node, it can serve 30,000 users per second. Okay. What if suddenly you are achieving or you are receiving more than 30,000 traffic? So your website gets a lot of popularity. Now this 30,000 will become 50,000 per second. 50,000 users per second are visiting your websites. Definitely your website will be down and slow. It will not respond that well. So by a Kubernetes engineer, you have to understand that scenario and you have to deploy another pod from the same Docker image. Okay. And make sure you are having the same label for both of the pod. So there will be no problem because service will be redirecting traffic to the multiple pod. It doesn't matter the service is of node port type or it is a load balancer type. Okay, either it is node port or load balancer. Both service can distribute the number of connection to different pods having same label. Okay, so that simply means it is going to distribute there. So that's why I'm planning 2 replicas initially. Okay, because maybe I really understand that yes, I'm getting a lot of traffic these days. So this is my planning. Okay, so always planning is something. If one pod goes down, even between reason, at least I have another one. Okay, so I'm just saving it and kubectl create -f, my first replication controller. Yes, it got created. I can check it by replication controller by writing this complete big name, or I can just also write RC, replication controller. I can check the pods created by these. Yes, 2 pods are there. So they're just getting some random names, and if I'll show you -- show labels, X is equals to hello app, and that is very similar to the one that I have given here under my metadata section. This is my label of pod, and that is having by both the. So it's very easy, very simple that yes, I have these pods running. Definitely. Now to access this, like we can expose either pod or replication controller to create a service. Okay, so I can either expose pod or replication controller to create this in a service. So what I'll do, I'll use kubectl expose replication controller, and replication controller name is this -- type node port, then -- port 80. Okay, so I'm just checking it again, get SVC, and yes, I'm getting 30183 port number as a node port, 30183. Now 30183 I can just write here along with my master or minion IP 30183. Yes, I am getting my web page. Okay,
and it's pretty working fine. Now the traffic that I'm sending, it may go to any of the pod either one by one or parallel. It doesn't matter, right? If I want to show you one more thing, that exactly these pods are running on a same worker node, okay? It doesn't matter actually. It can be randomly go to different nodes. Although as of now, both the pods are running on the same worker node. Okay, so it's a very luck by chance, right? Luck, very by chance thing, because both are running on the same worker nodes, but they can run on a different node as well.